Welcome back, guys. In the last two videos, we had seen how to convert decimal to binary and vice versa, and decimal to octal and vice versa. So in this video, we shall see how to convert decimal to hexadecimal and then hexadecimal to decimal. Now, before getting started with this, let's just take a look at a small chart which will help you. Now in this chart, we have few decimal values and few hexadecimal values. Now we already have discussed that hexadecimal has base 16 and it consists of 10 digits and 6 letters. So until 9, the decimal values and the hexadecimal values are all the same. But after that, decimal 10 is equivalent to hexadecimal A, decimal 11 equivalent to hexadecimal B, 12C, 13D, 14E, and lastly 15 is F. And you shall remember this chart. It is very important. Now let's get started. Suppose we have a decimal value 173 and we have to convert it into hexadecimal format. So in order to do it, we simply need to divide it by 16. In case of binary, we used to divide by 2. In case of octal, we used to divide by 8. And in hexadecimal, we divide it by 16. And rest of all is same. So if we divide 173 by 16, the quotient is 13 and obviously the remainder is, quotient is 10 and the remainder is 13. And from this table, from this table, we know that decimal 13 is represented as D. Therefore, and decimal 10 is obviously represented as A. Therefore, we have 173 base 10 is equal to AD. Why? Because 10 was the quotient and hexadecimal equivalent of 10 decimal is A. So we write it first because we always use bottom to top approach as we have already discussed earlier. And the remainder was 13 whose equivalent hexadecimal is D. So we have 173 base 10 is equal to AD base 16 or hexadecimal. Now let's take a look at an example in which we have a decimal part as well. So it is same as earlier. First of all, we divide this integer part by 16 to get the equivalent hexadecimal. So if we divide 41 by 16, obviously the quotient is 2 and remainder 9. So the hexadecimal equivalent of 41 decimal is 29, taking bottom to top approach. Thus, we get 29 over here and we place a decimal. Now for this floating point part, what we do is we will multiply it by 16 and upon multiplication, we get 11 over here, and in the decimal part we do not have anything. That means we get a perfect 0 in the first go itself and hence we do not continue. And we know again by this table that the hexadecimal equivalent of decimal 11 is B. Therefore we write this 11 as B over here and hence we get 41.6875 base 10 is equivalent to 29.B base 16 or in hexadecimal. Now that we are done with decimal to hexadecimal conversion, we shall see hexadecimal to decimal conversion. Say suppose we have 8F, that is obviously in hexadecimal, and we intend to convert it into decimal number system. So first of all, we see again the positional weights. So the positional weight of F is 0 and that of 8 is 1. Thus, what we write is 8 into 16 to the power of 1 plus F into 16 to power, F into 16 to the power 0. So 8 into 16 to the power 1 is 128 and F, let's take a look at this one. F means hexadecimal, F means decimal 15. So we have replaced this f with 15 over here. Therefore, we get 15 into 16 to the power 0, which is obviously 15 into 1, that is 15. So 128 plus 15 gives 143. Hence, the hexadecimal equivalent of 8f, sorry, the decimal equivalent of 8f is 143. Now, we take a look at this one, 29 point B, that we just did in the previous example, the previous conversion. So 29 point B, the positional weight of 9 is 0, positional weight of 2 is 1, and we have this B after the decimal, thus its positional weight is -1. So we write 29.B16 is equal to 2 into 16 to the power 1 plus 9 into 16 to the power 0 plus B into 1 by 16. Again, this 1 by 16 is nothing but 16 to the power -1. Now, this B in hexadecimal is equivalent to 11 in decimal. That's why we have replaced this B with 11 over here. Now we get 16 into 2 is 32. 9 into 16 to the power 0 is obviously 9 plus 11 by 16. This gives 41 plus 0.6875. So the equivalent decimal is 41.6875. Now let's take a look at this one. We have 7DE, which is obviously a hex number or a hexadecimal number. So positional weight of 7 is 2, positional weight of D is 1, and E is 0. So what we write is 7 into 16 square plus 13 into 16 to the power 1 plus 14 into 16 to the power 0. 16 square is 256 and this 7 remains the same. And over here we get 13 into 16 plus 14 into 1. Upon computing this, we get 1792 plus 208 plus 14, which is equivalent to 2014 or 2014. Therefore, the decimal equivalent of hexadecimal 7DE is 2014. The conversions are quite simple, and in the upcoming video we will just see how to convert. We will see some more conversions, that is, say suppose if you want to convert from binary to octal or vice versa, and binary to hexadecimal and vice versa. But for that one, you need to practice this properly, and most importantly, you need to take a look at this table very nicely and you must understand it, because even a slight mistake would lead to a completely different answer, and this particular chart is very important. So that's all for this video. Thank you.